Hello, welcome to Ekidel. My name is Justice Umoka. I am your instructor. Today, we will be learning how to design a part foundation for a water tank stand here in Protastructure. Looking at this structure right here, this is a water tank stand, and also the water tank stand is carrying a tank having a capacity of 50,000 liters of water. And also, if you look at this water tank stand, you will notice that it also has a staircase ladder which can be used to access the top of this water tank stand. And we in our last video we did a video on how to model, analyze and design the water tank stand just like this, and also how to create a steel staircase ladder and also analyze and design a steel staircase ladder just like this. So if in case you missed our video, you can just check on the description for the link, or you can check on our videos right here in Ekidel to see how to model, analyze and design this water tank stand using Protastructure software. But for today, we will be performing the foundation design of this of this water tank stand right here in Protastructure. So this is a part foundation, as you can see right here. This is a part foundation having a depth of 350 millimeter, so and also a size of 1.3 by 1.3 meters, which is almost uniform except this, which is 1.4 by 1.4 meters. So by the end of today's lesson, you will be able to design a part foundation right here in Protastructure. So just sit tight while we get started. Today we will be performing the foundation design for this water tank stand right here in Protastructure, and the type of foundation we will be using is a pad foundation. Although I will teach you two types of foundation using this particular structure, which will be a pad foundation and a strip foundation. But for today's lesson, we will first of all focus on pad foundation. So let's get started for the foundation design of this water tank stand here in Protastructure. So to begin your foundation design for any kind of structure, the first thing you do is to go back to your plan view and then go to your story 00 right here. So you click on your story 00 to make sure it is active, because that is the only place you can start your foundation design. Then right now, like I said before, we will be performing two types of foundation using this structure. But for now, we will first of all focus on pad foundation, and in our next video we will now do a white strip foundation. So I will urge you to subscribe to my channel if you have not yet subscribed, and I will also say you should share this video if you have also subscribed. Share this video with your friends so that they will also benefit on how to use Protastructure to model, analyze and design concrete and steel structures. Okay, so to perform a part design for this water tank stand, the first thing you do is to click on story 00 like I told you before. Then you can now click on one of the steel columns, right click, and then you say insert part base. So you click on this, insert part base. Then you wait for a dialog box to appear. A dialog box of the part base will appear, where you begin to choose the footing depth and also the bearing capacity of the soil, and also where you also specify the kind of reinforcement, the size of the reinforcement you will use for your foundation. So this is the dialog box right now. You can see part base properties projects, which is water tank steel design. So you can choose to change this footing label, but you can choose to change it to, let me say, part base 1, or you can say footing 1, anyhow you want. But this is not really something you can take serious, you can just leave it as default. Right now you do right now that is more serious when you're performing your foundation design is first your footing depth. So for a part foundation, what is necessary to do is to make sure you impute your footing depth accurately, your bearing capacity accurately, your concrete cover, which is already default, and the size of reinforcement that you want to use. So for now, let's start on the footing depth. So the footing depth, since this is a water tank, and knowing that this will have a pedestal, so when we go to our Prota detail, we will have to impute that pedestal. So for now, we are only designing the footing for we are only doing the footing base, which is the foundation. And when we now get to the Prota detail, that's when we can now insert pedestal, which will now carry the base plates for the steel, where you have to bolt the this steel stanchion with the concrete pedestal, and then which will now be tied with this foundation base. So for now, let's get started. So we go now and choose our footing depth. So I will take my footing depth to be 350. Let's see if that will pass. If it didn't pass, we'll come and increase. Then the next thing, I'll leave here as default. Leave here as default. You can check in my previous videos on foundation design. I really explained all these parameters if you have to put it or not. So for now, you only put your footing depth and then you go over to your allowable bearing capacity. It's like I told you before, I always do a practical base. So this is a live project. This this water tank stand is a live project which is already under construction. So from the bearing capacity and from the soil test, the bearing capacity of this soil is 150 millimeter for 150 kilonewton per meter square, sorry, which is the allowable soil stress, or the allowable stress of soil. So the next thing right now, I used the reinforcement of Y16 and also a reinforcement of diameter of 16. And then I will now click on calculate. So by clicking on this calculate, it takes the whole parameter that we have already imputed right here to now calculate, to now size and also calculate the footing against punching. So right now, first of all, I want a square footing, so I'll click on square footing. Now you can now see that the size of our footing is 1200 millimeter by 1200 millimeter, and it is at the eccentricity of 0 and 0, which means that this steel columns is at the midpoint of this our footing. Now, if I mistakenly impute any value right now, let me say I input 200, you will see what will happen right now. These columns here will tend to shift. So I input 200. You can see that the column have shift, but it is good to leave this eccentricity as 0. So I'll click back here and you can see that. So the next thing right now that is more important in your foundation, in your part foundation design, is to check for your punching check. This punching check will tell you if this footing depth that you imputed here is sufficient to carry the load coming down to the foundation. So the first thing you check for this punching check is to check for the punching check at column face. This must be okay, this must be okay, and this must be okay before you say your punching check is okay. The next thing again you check again is for your shear. It's for your shear for the footing. This must be okay, this must be okay, and this must be okay. And also on the y direction, this must be okay, this must be okay, this must be okay. If you find anything about if any of this okay turns to fail, that means you have to go and increase your footing depth. But for this case, we are having this 3, okay, okay. we are having this okay, okay, and everything here is okay. So we can now check. The next thing to check is our spacing. You can now see that the spacing of the reinforcement on the x direction um is diameter diameter 16 at spacing 250 millimeter, and also on the y direction is diameter 16 reinforcement or at spacing 250 millimeter. Now if this spacing becomes very small, let me say below 100, that means that you need to go and increase your size of reinforcement, because the minimum spacing you have is that you can allow is 100 millimeter. But for me, I don't really take the minimum. I used to allow a minimum spacing of 125 millimeter or at least 150 millimeter. So, but for this case right now, you can see that we have up to 250 millimeter, which means that the size of the reinforcement that we choose, which is the diameter 16, is okay for this footing design. So with this, I can now click OK. And then I can now click on OK. And then you will see the pad base, you will see the footing base inserted just right here, titled footing 1. So this is the footing base, which is titled footing 1, which is now 1.7 by 1.7. Let's see what happens there. Why it changed to 1.7? Because from the last time we checked, it was 1.3. Okay, so this is 1.7 and 1.7. So we just say okay, and we say okay. Okay, so right now, if we check on our 3D view to see what we have just inserted, you can now see what we have inserted. Okay, now we go back to our plan view right now. We go back to our plan view to insert the next footing. So we click on this column, right click, and then say insert pad base. So once we have set our first, once we have set these parameters on the first one, we don't have to set any parameters here again. We will just be clicking on calculate to use the same parameters for all other footing. Except any one fails, then we can now go and increase the depth of that particular one, or we will now have to change this choice of our foundation either from pad to strip foundation or to a raft foundation. So we click on square, and then we click on, then you now check if this is okay, you check if this is okay, you check if this is okay. You must check for your punching check if it is okay or if it is failing. But for this case, it is okay. You also check for your shear at X direction if it is okay. You also check for your shear again at Y direction if they are all okay. So this is okay. Then you also check for your spacing of reinforcement and your size of reinforcement if it is okay. But for this case, the spacing is okay. That means our size of reinforcement, which is diameter 16, is also okay. So with this, I can now click on OK. And then I'll click on OK. Then I go over to next. I'll have to delete this. I think there was something happened when we applied that eccentricity. That's why the size have to increase. So I'll just delete it and repeat base and then calculate and then square. You can see right now when we touched this eccentricity, that's affected the size of our footing. So right now I'll check this. Okay, this must be okay, this must be okay, and our spacing must be okay, which means that the size of the reinforcement is okay. So I can now click on OK and then OK. Then I move on to the next. I click and say insert pad base, and I'll click on calculate, and I will say square and check for this if it's okay, check for this if it is okay, and check for this if it is okay, and check for your spacing. I'll click on OK and OK. You must check for that punching check, and you must check the shear, and you must check your spacing of reinforcement. I click on insert pad base to put this, and I click on calculate, and then I click on square footing. We have the same we almost have similar size of footing, which is 1.3 by 1.3 meters, and you must check your punching check. It is okay. For this case, it's okay. you check for your shear at X direction. In my own case, it's okay. And you check for your Y direction. In our case, it's okay. And you check for this. It is you have to check for spacing. For this case, the spacing of 250 is okay. And then you click on this, and then you click on this. And then I'll go over to this and insert. So I'll just be fast because since you already know the principles to follow, this is colon axial load not defined. Okay, I'll click on this. Then okay, since you already know the principle, so I'll just be going. I'll check my okay, and this is okay for me, and I'll click on this and then click on this. Then I'll also go to the next and click on this. Right click, insert part base, and then I click calculate, check on my square footing, check on the punching, check if it's okay. The shear, this must be okay, and also this spacing must not be lower than 100 millimeter, and this 100 millimeter, and I'll click on okay, and then I'll click on okay. Then the next thing right now, I'll click on this to insert. Right click, insert part base, and then click on this, and then click check, and then I'll click on check on this if it's okay, and I click on okay, and then okay. The next thing right now, I'll click on this, right click, insert part base, and click on calculate, and then I'll check my square footing. You must check for a punching check. This must be okay, this must be okay, and this must be okay, and your spacing must not be lower than 100 millimeter. So I click on also on this side, I click on okay, and end okay. The next thing right now we'll do again is to let me insert this one. I click insert part base, and then click on calculate, and check this square footing, and check my punching check this shear failure, and check this shear failure. They must be okay and okay and okay. Any atom of failure on this punching check, you go and increase this footing, you go and increase this footing depth, and any atom of failure on this shear and on this shear, you go also and increase this footing depth. Any atom of failure on this spacing, if this spacing is below 100 millimeter, then you also go and you go and increase your size of reinforcement. To you can choose a higher diameter, which for in our own case here it is 16, and our spacing is above 100 millimeter. So this is okay. I can now click on okay. So I will not explain again on this because I've already explained more just to save time on this video. So I click on this, right click, and say insert part base, and calculate, and then square, check on this, and this, and you say okay and okay. Then also we go again by clicking on this, right click and say properties, and then we go here by clicking this, calculate, square this, and then check on this, and then you say okay and okay. Now we go again by now I will try to make one of these footing to fail, so that you can see what you do when one of your footing fails. So let me change this footing depth to, let me say, 200. Let's see if this will fail. Then I'll also change this size of reinforcement to diameter 10 and diameter 10, and then I'll now click on calculate. Let's see what happens. I'll now go again by clicking this, squaring this. Okay, this is still okay, this is still okay and okay. Okay, let me click on okay. See, from 150 to, let me say 35. Okay, let's see if that will fail. Now click on calculate, and I'll click on square. Okay, now you can now see that on our punching check, there is failure. You can see this is failing, this is failing. On our shear, it is still okay, and on our spacing of reinforcement, we are having 75. So this right now, 75 is telling us that we should increase our size of reinforcement, our size or the diameter of the reinforcement, and on this failure, it's telling us to increase our depth of footing. The reason why this happened is because I changed the bearing capacity. So the program is seeing that this bearing capacity of 35 is very low, which means that part foundation is not recommended to be used for this kind of bearing capacity. So what is okay to use, the kind of foundation that they can use for this kind of bearing capacity, which is below 50 kilonewton per meter square, is either a raft foundation or a pile foundation. So let's just go back to what we have before, which is 350. So you have seen how foundation used to fail, how a part foundation used to fail. So we can go back to here as 150, and what again do we have? That's okay. Go back to this as diameter 16, and this diameter 16, and then click on this, and then click on square. So you can now see that now is now okay. So you have seen what happens and how this place used to behave when there is failure, and how this place used to behave when the size or the diameter of the reinforcement is not sufficient. So you have seen. So you can now click on OK and click on OK. So with this, we have concluded our part foundation design here in Protastructure. So let's just check out on our 3D view to see what we have achieved. So you can now see what we have achieved right now. So this is how to perform a part foundation design for a water tank stand here in Protastructure. This same procedure of how to design a part foundation can also be used for any kind of structure, as long as you obey the same principles, checking your punching check of the footing, and also checking your shear failure of the footing, and also checking your spacing of reinforcement of the footing. So once you abide by that principle, you can use the same principle of part foundation design for any kind of structure, as long as you are doing it for a part foundation. So this is how to design a part foundation for any kind of structure, but in this case, this is a water tank stand. So thank you for your participation for this lesson. I would say you should share this video, and also recommend your friends to also come and subscribe, and also learn on how to model, analyze, and design any concrete building, also any steel structure using Protastructure software. So thank you for now, and watch out for the next type of foundation, which is strip foundation. Thank you, and God bless you.